Hello out there, welcome to this tutorial on circle theorems. In this video, we'll be looking at one of our miscellaneous problems. Here is the problem. An isosceles triangle of sides 13 centimeters, 10 centimeters, and 13 centimeters is inscribed in a circle as shown in the diagram. Calculate the radius of the circle. We have the diagram here and we have our isosceles triangle inscribed in the circle. We are required to calculate the radius. It is either we have the radius like this, or this. The first thing we do is we are going to draw the altitude, that is the height of the isosceles triangle, which is of course from the base to the vertex of the two sides that make up the equal sides. So we draw from the vertex to the base here. So the point here is going to form the midpoint, and since this is 10, we are going to have this one to be 5 centimeters, and then we have this as right angle. We can now find the height. Finding the height, we label the triangle. This is A, B, and C, which means we are going to find MC, which is the height of the triangle. Using Pythagoras theorem, we have MC squared. Okay, it is not the hypotenuse, is equal to the hypotenuse squared minus the square of the third side. 13 squared is 169 minus 25. Since 5 squared is 25, this is giving us 144. MC squared is 144, where MC is the square root of 144, giving us 12. So we have the MC, which is the height of the triangle, to be 12 centimeters. We can then get our radius here. We call it R. Remember also from the center of the circle to C is also the radius. So we have radius here, radius here. We can then calculate OM in terms of R. To calculate OM in terms of R, since MC is 12 and OC is R, therefore MO will be 12 minus the radius. That's 12 minus R. That will give us the OM or MO. We then go ahead now to look at triangle AOM. So if you look at that triangle, it's also a right angle triangle, and we have just stated that MO is 12 minus R. We can also use the Pythagoras theorem now to get our value of R, since we have one unknown here. So using Pythagoras theorem, this is the hypotenuse. We have R squared equal to 12 minus R squared, then plus 5 squared. So we are going ahead to expand 12 minus R squared. So 12 minus R squared will be 12 minus R multiplying 12 minus R. 12 times 12 gives 144. 12 times negative R gives negative 12R. Negative R times 12 gives negative 12R. Then negative R times negative R gives positive R squared. We simplify the middle terms here. 144 minus 24R plus R squared. So we have expanded this. We bring them in. 5 squared is 25, so we have it as plus 25. Collecting the like terms, I have R squared here, bringing this R squared to this side. I have minus R squared minus 24R coming to the left hand side. I have it as plus 24R. We are then left with 144 and 25 at the right hand side. The R squared minus R squared is gone. So we have 24R equal to 169. 144 plus 25 gives 169. Dividing both sides by 24, we're going to have R to be 7.05. 4 centimeters. After dividing 169 by 24, we are left with 7.04, which represents radius of the circle to 3 significant figures or to 2 decimal places. Since it is not specified, we have our results. And that's the end of solution to this problem, and this is where we are ending this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Also remember to subscribe to our YouTube channel. Until we come your way again, goodbye.